Hi, this is Ramesh, working as assistant professor in Department of Computer Science at JJ College of Arts and Science. Here I am taking the class about Quicksort in data structures and algorithms. So, what is sort? Sort means the array of elements are arranged in like either in ascending order or descending order. So, what is quicksort? So, most of the sorting techniques are using divide and a conquer approach. So, what is quicksort means here? A vast array is divided into two arrays, one containing values smaller than the provided value, that means pivot value, on which the partition is based. The other contains values greater than the pivot value. That means here, suppose I am choosing one value from the array elements like 25, that is treated as pivot value. The pivot value is placed in one position at your array by in array ascending order. Then the pivot value is placed one position. After that, the less than the pivot values are placed in the left side of the pivot value, and greater than the pivot values are placed in the right side of the pivot value. Okay, the quicksort algorithms uses recursive algorithm. That means recursive method means here repeatedly doing the process until we find the solution. So then how the quicksort works here? All the elements to the left side of the pivot are smaller than pivot, and all the elements to the right side of the pivot are greater than the pivot. Okay. After dividing the array into two sections, the pivot is set at its correct position. Then sub-arrays are sorted separately by applying quicksort algorithm recursively until we find the solution. Here I'm giving one example. Uh, for example, here I'm choosing one array that is named as A of uh, 5. That means here I am using 6 elements like 25, 10, 20, 15, 20, and 28. And here I'm using three pointers. One is location and left, and another one is right. Left and the location points to the first element of the array. Here the location and the left points at left position of the array, and right is pointed at right position of the array. Okay, by comparing a of location less than a of right, a of location means 25, a of right means 28, and compared with the less than operator, then 25 is less than 28. The condition is true, so we can move the position one position to left side for to of the right pointer. So the location is 0, left is 0, and right position is now 4. So pointer moves one position left side. After the movement, so no swiping, that means 25 is moved position to A of 4, then A of 4 is moved to A of 0. That means swiping occurred here. Then the location pointer is moved to A of 4. After that, A of location is compared with A of left. So here A of location value is 25, and A of left is 10. So A of location greater than A of left means we can move the left pointer one position to right side. So here the picture shows clearly about the movement of left pointer. Then we can compare A of location greater than A of left. A of location value is 25 greater than A of left. So condition is wrong. So we can move the left to one position towards Right. That means A of location value is less compared with A of location. That means A of left. Then the pointer moves to A of left location. So the A of location is placed in A of left. Since location is here, that means A of 2 having 25. So A of 25, sorry, A of 2 is 25 less than A of left. A of left means 25. So swapping up occurs. So no changes here made. Then the pointer right is chosen to compare here. A of location value is 25 and A of right is 15. So the value is compared with the less than operator. Then we can move right one position towards left. Okay. So the 25 is moved to A of 3, then A of 3 having 15 is moved to A of 2. So swapping is occurred here. After the swapping, we can show that means we can see the picture. The location pointer also moves to A of 3. So the A of location value is compared with the A of left. So A of left value is now 25. A of location also 25. So algorithm moves one left position. That's how it. A of left value is 15, then A of location value is 25. So no need to swapping occur because of left 15 is compared with 25 is less. So we can move the left pointer to right side. So finally, we get this left and right pointer at the same position, and the location also in the same position. So all three pointers are in the same position. We can exit this procedure. Okay. Now we can see the final. That means partitioned elements. The compare with the pivot, the left side values, the left side of the pivot is less than the pivot element, and the right side of the pivot position is having greater than the pivot elements. So sometimes we have chosen 25 is the pivot value, less than the 25 are placed in AF0, AF1 and AF2. Greater than the pivot element, the values are placed in AF4 and AF5. Finally, uh, the quicksort gives the location of the element that splits the array into two parts. Order of n operations are required. This is because of every element in the array is compared to the partitioned element. After the division, each section is examined separately. If the array is split approximately in half, then there will be log 2 n splits. Therefore, the total comparison required f of n equal to n into log square n. That means order of n log 2 n. The advantages of quicksort. Quicksort is an in place sort, so it requires no temporary memory. That is the main advantages of the and one of the important advantages in the quicksort. So no requirement of temporary memory. Then easily parameterized due to its divide and conquer nature, typically faster than other algorithms. These are the important advantages. What are the disadvantages here? The worst case complexity of quicksort is order of n squared. Suppose we are giving the sorted elements to find to make a quicksort. This is the worst complexity because of already arranged values are again compared to make ascending order. Well, thank you for this viewing.